Live from Utrecht, this is Bitcoin.
Explain.
Hey Sjors.
Hello.
So, here we are after weeks of you complaining to me, DMing me, asking me every week after week, Aaron. I want Nigel Farage to come to Amsterdam. Nigel Farage needs to be a speaker at Bitcoin Amsterdam. Finally, Sjors, I can tell you, he's coming.
Okay. I think I heard the rumor earlier today and I was like, okay.
He'll be there, so it's a happy day for you, Sjors. I know he's your favorite politician.
He is? Okay.
And you, dear listeners, if you want to see Nigel, the great Nigel Farage, in case anyone doesn't know this, I'm being a bit sarcastic. But in case you want to come to Bitcoin Amsterdam.
Does he even have a passport to travel outside the UK?
Yeah, I don't know why he would want to, right? But let me finish my thought. If you want to come and if you want to meet Nigel Farage or at least hear him speak, use the promo code SjorsNATO. Let's see if anyone out there can remember SjorsNATO and use it as a promo code. You'll get 10% off.
Okay.
That's my sort of, I'm now just shilling the conference before we start the episode, Sjors. I hope you don't mind too much.
That's what we did last time.
Yeah, I think it is the third time. All right, let's move on. Sjors, today you've got a new hobby.
I have a new hobby.
What am I looking at here?
You're looking at an anvil.
You've got an actual miniature anvil on your desk right here.
That's right.
And you're using that for what exactly?
Well, right now I'm just using it as a nice decorative element, but I want to hobby around a bit with these QR codes that you can basically put in steel plates.
Right, you're going to hammer your private keys into steel.
Well, or some testnet private key probably, but we'll see.
Fair enough. Yes. Well, so the specific thing we're going to discuss is SeedQR. This is something you proposed.
Yes.
I'd never heard of it. I don't know where you found it, and I think you didn't remember where you found it either.
I remember.
Oh, where did you find it?
Yeah, I was on Twitter, as I sometimes do.
As usual.
And I was doom scrolling, and then I saw this really cool video of somebody writing down with pen and paper a QR code, just with regular pen and paper, and scanning it, and it actually worked. So I was quite surprised to see that you can actually draw them by hand, and quite sloppily even.
Why is that surprising? That doesn't
I
surprise
thought
me at all.
I was expecting it to be very sensitive. So like if you don't print it with a computer and the squares are not perfectly square, then I thought it wouldn't work. But it turns out now you can do pretty sloppy work, and it still works.
Right. So basically, you can draw out a grid and start, coloring some of the.
Yeah, but I think he didn't
blocks.
even draw out a grid here. So yeah, it was just.
And it still works.
Yep.
Oh, that's actually pretty interesting then. So this was someone using SeedQR. Does this tie in?
Yeah.
With
So
what we're
I
gonna
was
talk
wondering,
about?
like, what is that? What's behind that? What's the standard, or maybe a proposed standard? And yeah, so there's apparently something out there called SeedQR, and the context in which it's used is a device. I guess we'll get to that later. It's called the device called the Seed Signer, and that is not really a company. It's just an open standard for how you can make your own device. So you buy, I think it's a Raspberry Mini or Arduino, something like that. Very tiny computer, has a little camera on it, and you install some software on it that's open source. And then you can use that to scan a QR code. And this QR code will then convert into your 12 words or 24 words.
Okay.
And vice versa, you can use a keyboard, or it's not really a keyboard, just a couple buttons to enter your 24 or 12 words, and it'll show you a QR code, and you can then draw that QR code on a piece of paper. That's kind of what it does.
Right.
We're getting a little ahead of ourselves, but that's what I was looking at.
Yeah, let's just take this one step at a time, and then we'll get to whatever you're talking about in a minute.
Okay.
Sounds good?
Sounds good.
All right, here we go. So, first of all, Sjors, how do people make sure they don't lose their Bitcoin?
They make backups.
Great.
Or they become a no-coiner.
Well, so the people used to make backups. Back in the days, we all made backups, which basically meant you literally backed up every private key you had, right?
Yeah, so I'm using the word backup very broadly, but back in the day, you actually had to make a backup in the more narrow sense that you click the button that says make backup and you store the backup somewhere else. So if you were using the old Bitcoin client before it was called Bitcoin Core, it came with a wallet. And yes, in order to not lose your coins, you had to make a backup of the wallet, but not just once. Initially, every time you made a new receive address, it would be a completely random receive address. So you'd have to make a backup every time you receive coins, or at some point, I think it was improved, so it would make 100 receive addresses in the background, and you'd make a backup of those 100 addresses. If you forgot to do that, you would suddenly lose all your coins if you restored an old backup.
Right. Okay. So the problem with this, for one, is you need a lot of, well, maybe not a lot, but you need to back up a bunch of data, one for each transaction, one for each receiving transaction, because ideally, of course, you make a new address for each transaction, as we've explained like 3 episodes ago, I think.
We've mentioned it a couple of times.
It's also somewhat everyone knows.
And so you didn't have to do it every transaction. I think you would have to do it every 100 transactions or something, and they would just make 100 backups, something like that. But anyway, if you forgot to do that, your coins, not only do you use new receive addresses, even if you use the same receive address every time, when you're sending coins, you create a change address, your wallet. And your wallet will create new change addresses,
right?
Because it's very disciplined. And so when you hit change address number 101 or whatever it was, and you don't have a backup of number 101, now all your coins went to this new change address and they're all gone.
If your computer crashes or something, yeah.
Yeah.
Okay, so this was improved. We're just going to have to kind of rush through this because we've discussed it before, and I think we've even had entire episodes about some of this stuff. Like, for example, the thing we're going to mention now are seeds. I think we've had a whole episode. It was an early episode. What is an XPub?
Yeah, that's a famous episode.
Is it a famous episode? Sure.
No, I don't know.
I think all of actually none of our episodes are famous, I'd say. BIP32, that's seeds. So what is seed? Am I saying that right?
Well,
no, I'm saying
seed,
it wrong.
yes, but it's not a mnemonic. So basically, a seed just means one key that creates all the other keys. So it's like a plant seed.
Right, yep.
And so what BIP32 did is you create this one master seed, master key, or whatever you want to call it. And that's the thing you back up, which is the first thing you do when you get the new wallet. You back up this master seed, and you're good. Then what happens is you have a tree of derivations, basically, so that each address is unique, but it is all derivable from this one seed. So that's how you can restore
just to jog my own memory, really. I mean, if I don't remember, probably some of our listeners don't. Is it essentially just the case that you generate a first private key and then you hash the private key and the hash and the hash and the hash, and that's just new private keys? Or is it a bit more complicated?
It is a bit more complicated, but it really boils down to that. You hash it and maybe you add the number 1, and there's some nuance there. But yeah.
That's essentially the gist of it. All right.
It's deterministic, so your wallet will know what to do.
Right.
Once it gets a seed, it will know how to find the addresses that you've used before.
Sure. Okay, now then I guess the problem here, again, we're rushing through it a bit through this part. The problem here is that remembering even the seed, even the first private key is a little bit hard. Not for you, of course, Sjors, but for regular people like me and most of our listeners, we don't actually remember kind of stuff. So we need something that's a bit easier.
Well, so the thing is, initially with the Bitcoin client, you would just back up on a USB stick or something like that, right? It'd still be a digital backup. And so some people would prefer to have a backup that's physical, that's probably written on a piece of paper. And that means, then it gets really cumbersome to start writing these hexadecimal things down, if you can even find them. So
right. It's not even about memory. You shouldn't even use your memory. You should write it down either way. But we need an easier way to write it down.
Yeah. So if you want to, and I guess that's another thing. So then there was this idea called BIP39, which is a mnemonic. And the idea is really you just take the letters or the hexadecimal numbers and you just map them onto words. So there's 4,000 words and each...
No, there's 2,048 words, I think.
Okay, some number. Those just map onto the numbers.
It's 2 to the 12th. 2 to the power of 12. That's 2,048.
That sounds like 4,000. Because 2 to the power of 10 is 1,000.
No, I'm pretty sure. I looked it up this afternoon, so I think it's 2,048 words.
Well, it's a large
But there
number.
may be several standards, right? Aren't there several?
Well, I'm talking about BIP39. So
Me too.
There's a number of words, which we'll have to look up. And those words just represent numbers, essentially. So that's that simple. And then...
basically, it's just the first word is number 0000. They all have 4 numbers, right? And then the second word is 0001, and that all the way through to 40.
Now, there is a little caveat there. It works one way, as in you start with the numbers. So the numbers are the seed you generated, essentially, your computer generated. and then they are converted to words. But when you use it, it's actually not using the words. It's not going back to the numbers. So when you enter the words, the next step in order to create this hierarchical wallet is to just process the words as they are written and hash that. It's a little implementation detail that you generally don't have to worry about unless you want to do translations. So basically, the first address of your wallet is derived. So you start with this random numbers. Those are turned into words, and those words pasted behind each other, and maybe with a little password behind it. Those are hashed, and that's where the first key come from. But that means that if you have, say, a German alternative for this BIP39, that if you have you start with the same numbers, but now you're starting to write German words, and when you hash the German words, you're going to get a different key than when you hash English words. So you cannot translate one seed into another. That makes no sense.
Right. Okay.
And this is relevant because that's one reason why I don't think it's a good idea for people to use BIP39 in other languages. Because in that case, you may have one piece of software that will understand what to do with the German words, but your other piece of software that you may want to use later, your other wallet, will not understand it. So because most of the support is for the English words.
Right. Okay. Well,
anyway,
I didn't know that. I also don't. Is it important for the rest of the episode, or
it's not important for the rest of the episode?
Nugget for our listeners?
It is one of those things that if we ever had to redo these standards, that we should do better.
Right. I do have another question. So some seeds have 12 words and some have 24. I think these are the two most common amounts of words.
Mm-hmm.
Why is there a difference? Is one just more secure, or?
Yeah, it's more bits. So 12 words means 128 bits of random data. So basically throwing coins. Yeah, you're basically throwing 128 coins. Or
4 heads of tails, yeah.
Yes. Or if you have 24 words, you're effectively throwing 256 coins, heads or tails.
Mm-hmm.
And that is not twice as secure. That is like
a lot more secure.
Yeah.
What's the number, Sjors?
Well, I don't know
from the top of your head. Come on.
Basically twice as many bits of security.
Yeah.
But that, it takes a lot more time to brute force it. Right? Because every bit you add means it takes twice as long to brute force it. If you want to guess what somebody's mnemonic is, you try one combination of words, you try another, you try another, you try another. And if it's a 2-bit system, if it's a 2-bit seed, well, then you just have to try 4 times. But if it is a 4-bit seed, you don't have to try 8 times, you have to try 16 times.
So is 12 enough then? Why don't all wallets just use... if some wallets use 24, why don't they all use 24?
I mean, ultimately, it's better to have more bits of security. If there's no trade-off, why not, right? And ultimately, in the long run, the worry is that as computers get faster or as problems are found, you need more bits to be really secure. And maybe one day we'll reach the point where 128-bit is not secure anymore, but then 256 will last us a bit longer. So it's that kind of long-term thinking.
Is it maybe also partly a human problem? Like some people will cut their seed in half, thinking if they hide them in different places, then they're good. But then if someone
so then you're getting really in trouble, right? Because if you have a 12-word seed and you cut it in 2, that's 6 words each, and that is only 64 bits of entropy. That's still a lot, but it might be within the realm of something you can crack. Because again, twice as long does not mean that it takes twice as long to crack it. It means it takes, exponentially longer to crack it.
Yep.
So that's indeed one of the risks, but I don't think that's the reason. So basically, you could say that the limit of Bitcoin, the way it's architected, is 256 bits. And that is because the hashes of a block, as well as the elliptic curve, all use 64 bits, 256 bits. Right? So if you have a way to crack a 256-bit number, like find the private key, etc., that's basically the security level anyway. So you might as well use
broken Bitcoin itself, yeah.
Yeah. So that's why I guess that's one argument to say, well, then why don't you use seeds that are at that limit? Yeah. It makes no sense to go beyond it, but it also makes no sense to stay below it. All things equal, because you do have to write these things down or do something else with it. And if that's too much work, then people won't do it. And then you just lose your coins. So the benefit of 12 words is that people are more likely to write them down.
Okay, now let's get to the meat of this episode. I think that was a long recap of stuff that people already knew, or at least most people already knew most of that. So now we're getting to SeedQR, and this is your hobby project. So I guess yours, just explain what it is.
Yeah, so it's, as far as I know, it's a proposed standard,
Mm-hmm.
and there are some tools that are using it. And the idea is that you take these 12 to 24 words, and rather than writing them down as words, you convert them into a QR code. Because remember, these things represent numbers. So you just take the word, find the corresponding number, and now you have a bunch of numbers. And if you have a bunch of numbers, essentially if you have 128 bits of data or 256 bits of data, you can squeeze that into a very small QR code.
Right.
And
So right
QR
now, a
codes
lot
are
of
nice.
people. So right now, a lot of people are storing their Bitcoin, essentially their private keys, as a list of, or at least their backup as a list of words. And according to with this standard, they could back up their keys as a QR code, which they hide somewhere.
And so one benefit of that could be...
Is that new? I mean, I've never heard of it, but it
I think it's
sounds like a fairly
fairly new.
obvious thing to do, but it's new.
Yeah, I mean, really depends on your use case, right? So if you have your keys in some very far away cold storage place in the middle of the Antarctica, well, it may be useful for you. If you need those words anyway, you can either type them or you can scan them, right? Those are the two ways you can enter them back into a machine. And since most hardware wallets are a pain in the ass to type on,
Mm-hmm.
maybe using a camera might be easier. But I think only the Jade hardware wallet and the Spectre DIY wallet have cameras. So there's only limited use for QR codes.
Okay, so the general idea is we're using a QR code as a backup. What are the challenges here?
Yeah, and not just as a backup. It could even be, let's say you have a phone wallet, right?
Right.
And when you're walking around with your phone, maybe it's a phone wallet that you don't use for shopping, but you do use it for your I don't know, everyday stuff. It's not like cold storage. It's not a huge amount of money. But when somebody robs you in the street, you don't want to be able to give them Bitcoin, so you don't want to have the private keys on the phone itself. You want to have them somewhere safe at home. And so then a QR code could be useful because when you do want to use it, you just scan the QR code, and now, boom, you can spend your Bitcoin. But when you're on the street, nobody can rob you. If they go to your home, they can. That's the trade-off.
Right. So the idea there would be that your phone doesn't actually store any of the keys. It just scans them for one-time use. It scans
Exactly.
the QR code for one-time use and then forgets it. And it can be a phone. It can also be another device. Of course, it could be a hardware wallet that
Yes.
operates like this. So then the keys aren't even on the device.
Yeah, well, they are when you're using it, but
Right.
After that, they're not. Well, unless it was compromised.
Right. So rather than thinking of it as a backup, in that case, it is essentially your actual cold stored wallet.
Yeah, or at least your actual offline, semi-offline wallet or something like that.
Right. Okay, so what are the challenges to accomplishing this, if there are any?
Well, for one thing is, again, it depends on the use case. For the easy use case where you are printing a QR code with a physical printer, then I guess it doesn't matter, right? You can make a very big QR code or a very small one, doesn't matter.
Mm-hmm.
But when you, as we described in the beginning, you want to write down your QR code on a piece of paper, which you can draw, it's nice if the QR code is not too many little points because it's very tedious to do it. And if you want to, put them on metal, then... you really don't want to have 5,000 little points that you need to put on the QR code.
Right, and I guess the reason this matters is that you ideally don't want to have your private keys touch a computer at all, possibly, or
Exactly.
a printer at all.
Exactly.
These things can be hacks, and I think some printers even have memory of stuff they printed. And ideally, it just flash on your hardware wallet or something, and then you write it down with a pen and paper.
Exactly, and that's what the
something
Seed
you
Signer
can-
does. So the Seed Signer, this sort of open source device, you can buy off-the-shelf components and make it yourself. What this device does is you enter your words, and it shows you the QR code, or you scan the QR code, and it shows you the words. And then I think that device can also sign things. But maybe you don't want to use that part. Maybe you want to use your regular hardware wallet for the signing. So you then take your mnemonic and put it in your regular hardware wallet. Something like that. That could be the operation flow. And that means you're not using your main computer, which will probably have millions of viruses on it. You're not using your printer, which will probably have millions of viruses on it. And then it's really important, because you're doing this step by hand, you're drawing a QR code, the drawing part should be as little work as possible.
Right.
So then they've done some research about how small these QR codes can get. And
How small can these QR codes get?
for 12 words, you can use 21 by 21 points.
Is that...
And a large part of that, if you look at a QR code, there's these giant rectangles, right? So it's 21 by 21, including those giant rectangles.
Yo, what is going on, guys? We are proud to have Voltage as a sponsor of this episode. How many of you developers out there have wanted a streamlined infrastructure provider for your particular project? Well, I'll tell you what, Voltage is the Bitcoin infrastructure provider you have been looking for that makes building on Bitcoin quick and easy, whether it's Bitcoin nodes, Lightning nodes, BTC Pay, and so much more. But don't take it from me. Just ask the guys over at Amboss, Sphinx, Podcast Index, and Thunder Games, and so many others that you guys already know and love. Their enterprise-grade products make it fast and easy to build, deploy, and scale your next project. So make it easy on yourself. Even normie plebs can use the dashboard or API. Don't wait before the next block confirmation. Let your team focus on building great products and let Voltage handle all the rest. Voltage is your go-to zero management Bitcoin infrastructure solution.
How small can QR codes get in general? Is there any
21 by 21, at least.
Is that the smallest type of... Are there
I believe
types
that
of
is
QR
the
codes?
smallest type of a regular QR code.
Right.
There is also a micro QR like standard that is even smaller, but that is useless for this purpose. So if you look at my book, maybe I'll just shamelessly shield that I have a book.
Yeah, we're shilling all the way in this
Bitcoin,
episode.
a work in progress. Or just Google Bitcoin Sjors. You'll need to know how to spell that anyway.
No one knows Sjors.
That's all right. Who? What was I saying? Yeah,
You
the
were
book
telling
actually contains QR codes that will take you to various resources, right? So you don't have to type the whole URL. You scan the QR code, it takes you to a short URL.
Right.
Those short URLs fit exactly into the smallest possible QR thing of the 21 by 21. So that's HTTP : / yada yada yada.
Okay.
But you can also put a seed in it.
So the smallest, at least the smallest sort of regular QR code is 21. Do you know what QR stands for, Sjors?
Quick response.
Very well. Very good. So the smallest QR code is 21 by 21. And then there are bigger ones.
Yeah, and so the reason you want to use bigger ones is, for example, because you have more words that you want to put into it.
Right.
So I think you need a 25 by 25 to have 24 words. And the other thing you can do is increase the error correction. And so what a QR code does is it shows you, a QR code starts with the actual thing that it's describing.
Mm-hmm.
So say a URL, a piece of text, and then it has a bunch of extra bits and a bunch of extra pixels. And their purpose is to basically help the device that's scanning it to correct for errors because the camera might not be accurate.
Yeah, or your ink may be blurry. Or
yeah, so
that
basically, some people abuse this feature. They'll put the company logo in the middle of a QR code. And what that does is basically it obscures part of the QR code. But because it has so much error correction, you can actually obscure 5 or 10% of the QR code and still read it. That's the idea. We talked about error correction in an earlier episode, I believe, about this mempool sync project.
Okay.
Mini sketch.
I don't remember. Well, I kind of remember vaguely. But let's get back to the point. So we're using 21 by 21 QR codes.
Or bigger.
Right?
Yeah. The SeedQR standard uses several different sizes of QR codes.
Right. And is there any sort of... I recall they're doing some tricks to actually make it fit. Is that not the case?
Yes. So, yeah, exactly. There are two ways to put the data into the QR code.
Mm-hmm.
One is a way that is as compact as possible. That's where you get to 21 by 21. And the other is a way that other apps can actually read it. So the problem is when you use the most compact way to store it, there are not a lot of off-the-shelf applications that can actually read this QR code. So if you point your phone at it, if you use this very compact form, your phone will be confused. It won't understand what to do with the QR code.
Right. So
that's kind of a feature actually because you don't want it to. But
they've used optimizations that other apps don't understand. Is that the right way
but
to put it?
basically, when you scan a QR code, your phone is generally expecting a URL or at least regular text. But these things will use full, basically 256-bit ASCII. So if you ever I don't know if you've ever seen like some binary file and you open it up and it has all these symbols and your computer starts beeping at you.
Yeah.
Yeah. So that's basically what's in the QR code too. It's using all the bits it can, and so your phone thinking it's text will render complete gibberish. In fact, it will just not work.
Right. Okay.
But I think that's all solvable.
And what you were saying is that in a way it's kind of nice that it does that, because if some random person finds this QR code that has all your money on it, then it's kind of nice if they don't understand what it is, right?
Well, that's one nice thing about QR codes. So now, you can start thinking about where could these fit into your security model. Well, if you're traveling with 12 words written on a piece of paper, if the customs search your bag, they'll see the 12 words, they know what to do with it. Maybe if you have, say, a vaccination passport that has a bunch of QR codes on it anyway, you kind of shove in your little Bitcoin backup in that passport and maybe they won't see it. But that's always a little scary.
Okay, so far this all sounds great. Also kind of straightforward. Is this just a straightforward episode, or is there some magic still awaiting in the corner?
My magical,
where are we taking this?
My magical suggestion would be that, yeah, this is pretty straightforward, but I would say that the downside of QR is that it is designed for computers. Mm-hmm. So it's very easy for computers and cameras to scan it. It can read it by hand, as in there's a couple of YouTube videos and documents that you can read that will explain to you, if you see a QR code, how to read it, but it's very difficult. So what I would like to see is another standard, a new standard, that kind of looks like a QR, but that is much easier for a human to read. So that means you wouldn't even need the seed signer device. You would just be able to take a pen and paper and just, look at where the squares are and do some math, and then you would actually know what the seed is.
I'm just thinking of the.
Yeah, I know which XKCD you're thinking about.
Which one is it?
But this standard might actually already exist.
There are 14 computing standards. 14 ridiculous. Anyways, I think everyone knows it. I'm not going to finish the joke.
Yeah. So I don't necessarily think there has to be a new standard. There may be that there's already are standards out there that are designed for humans to parse rather than for cameras to parse. Yeah.
Okay. Well, let's see if someone develops that then, Sjors. Why don't you develop a new standard? We need the 15th standard. I'm
not a encoding master.
Okay. Well, I'm not going to do it either. So hopefully one of our listeners will feel inspired by, I'm your hoping encouragement.
I hope SEPA picks it up, because it'd be nice to have some error correction. Let's say you have a QR code, right? And QR code is if you read it from left to right, basically it's either black or it's white. So it's like a bit. So you could imagine having a device where you're clicking a button, either the left button or the right button. If you see a white pixel, you click the left button. If you see a black pixel, you click the right button. And then based on that click pattern, it reconstructs your seed. And it's nice if there's error correction while you're doing that. So rather than typing all the 24 words as you would now, and then it says, nope, sorry, it's wrong. Every 6 or 7 characters, it would tell you, no, you did something wrong. And then you know that you have to go back and check the last 7 characters. Because, it's not easy to manually type something like a QR code without making mistakes. So I think there's promise there.
Okay.
But that's all I got.
Okay. So when are you going to make yours?
Oh, I don't know. Whenever
your steel plate?
Whenever it arrives. I'll go play with it.
You're waiting for the actual plate to arrive? That's what you're waiting for?
Exactly.
All right. Well, you got the rest of the tools ready. Sure, I think that's it then. I think that's our episode.
Sounds good. Thank you for listening to Bitcoin
Explained.